Hello, everyone. I'm just going to wait a few minutes so that people can join. Thank you for joining us, people who are already here. Hi. Welcome. We'll start at about 2 or 3 minutes past, just to give as many people as possible to join. I know that a lot of people might be watching on demand as well, so no worries. We won't keep those who are here waiting. Don't worry. That nice awkward we just sit in silence bit. Okay. Hi, everybody. Everybody who's watching on demand, everybody who's watching it live, everyone who's going to join us as we move forward. My name is Georgie, and I am the head of marketing and partnerships for Witekio, and I am your host today. Don't worry, I'm not going to be talking about technical things. I'm going to leave that to our lovely speakers. I'm just here to answer your questions, make sure that the questions are answered by our speakers, and to make sure everything goes smoothly, which we can't always promise will happen as it's live, but we'll hope. Today's session is all about powering up innovation, Linux on MPUs for next generation EV charging solutions. So a bit of a hot topic, as EV charging solutions seem to be the next gold mine, right? That seems to be what everybody's saying. Between us, Witekio, I'm an STMicroelectronics, are going to be talking about how EV charging industry is transforming, the value of ARM architecture and the benefits of system ready. We're going to meet the STM32 MP1 industrial grade MPUs. We're going to talk about how ST hardware can meet EV charging application performance needs. Then Witekio is going to take over to talk about Yocto tips for MPU, how to fast track your development for a EV charging solution with Witekio. And we're going to look at an EV charging use case that we've actually made and has been displayed in different trade shows. You might have seen it if you've seen us in Europe or even at the ST Technology Days in Santa Clara, which is a Witekio solution with ST hardware. So I'm going to hand you over to our speakers. First of all, the lovely Pierre Girl from Witekio. Thank you very much. And don't forget to ask your questions in the chat and we will answer them at the very end.
Hi, everybody. Thank you, Georgie, for the introduction. So I'm Pierre. I'm leading the solution at Witekio for now years and helping OEMs to build the best solution to provide a high-quality product on the market.
Thank you, Pierre. So Ludovic Dupré, real pleasure to present this webinar with Georgie, you, and Chakra. So hello, everyone. I'm Ludovic Dupré from STMicroelectronics. I'm working in the marketing team of the ST microprocessor division. I'm business development manager covering worldwide STM32 MPU lines activity. And so I am promoting this amazing ST's microprocessor portfolio. So I hand over to Chakra.
Hi there. How are you? This is Chakra Kella. I'm part of the IoT segment strategy team, and I'm excited to present here some of our efforts on Linux, and pretty excited to get started here. Okay, let's jump right in. Welcome to the webinar, and as we start the webinar, I wanted to just look at how big the EV market is and highlight some of the key things about this market. So if you look at it, I mean, the entire market is growing at an exponential pace. And just in the US alone, the US Department of Energy has shown that the number of ports, they projected it to grow at double-digit high 22% or so CAGR. And this is a significant growth. And if you think about the whole world, including developing nations where some of this revolution has not yet started, you can see how much potential there is for this market. And with this, you'll also realize that the market itself is changing. And the EV charging infrastructure about 5 to 10 years back looks very different than what's it today. And it will be very different 5 or 10 years from now. New features are being added, and new capabilities are being brought into the picture. So you need a lot of future-proofing, and you need new features like OTA, display capabilities, and new capabilities. So you need a proper and robust operating system that actually can support it. Now that brings us to the next slide. This is where Linux is very powerful, and there are many advantages of using Linux in a new and growing and evolving and dynamic market like EV charging. You have capabilities like multi-threading. You have a robust ecosystem behind you. The software development is more stable and it's more simplified. And an advantage of building a system on a rich operating system like Linux is that as the market evolves, you can keep adding new features. You can maintain it better. And you can use, when you progress and move to better processors in future, then you don't have to throw your code. You can reuse a huge chunk of the code. So with all these things, Linux makes a very strong case of being used in this market. So I just wanted to start off acknowledging the importance of Linux in this market. Okay. Now, moving ahead, I'm from ARM, and I'm giving you our view on why we believe we are one of the better choices for building on a Linux-based system. So first and foremost, the ARM IP, it has lower power, it's more energy efficient, and there are many security capabilities. So that goes without saying. In addition, there is a lot of investment that we are doing in making sure that developers have a seamless experience. And we are investing, and I'll talk a little bit more about what we do in different pieces of the software stack. In addition to that, if we look at our IP portfolio, we have a very compelling portfolio starting from the low performance end all the way to much higher performance spectrum. And this is represented by some of the processors that you're seeing on the top. Now, in addition to that, we also have additional IP like a GPU, ISPs, and MCU for heterogeneous computing, as well as NPU for AI acceleration. So we have a whole host of IPs to supplement the basic microprocessor product portfolio. And this will help from a lower performance point to a very capable system like an industrial gateway or so on. So for something like an evolving application, sticking with ARM has a lot of value, and that's what I wanted to represent in this slide. Now, open source is extremely important, and this is just to highlight our commitment and what open source and Linux means in the industry. So there was a survey earlier this year, and according to the survey, Linux is by far the most favored operating system for building something on embedded. So this clearly demonstrates that the developers out there who are building all these unique experiences, they prefer Linux. And then over half of all these systems are all ARM-based. Now, that goes without saying that we have a responsibility to keep committing into the development of Linux. And we are one of the top 3 contributors, along with Linaro, into the Linux open source. And finally, if we'll just take one step back and look at our commitment to open source, we have over 1,000 projects which we are actively contributing in the open source across ARM. So moving ahead. Now, this is a complex slide. This basically shows different pieces of software that the software developer has to worry about, and then how ARM is trying to help with each of these layers. There are different ingredients. You don't have to go through each of those, but there are different layers like BSP. There is something to do with security, connectivity. So there are multiple software stacks, and ARM is making sure that they do investments in each of those so that you have a seamless experience when you start developing or when you start on your journey of a new project. So the key takeaway here is that when you look at the solution, there is a lot of layers, there are a lot of pieces that goes into building a solution which is very stable, which is very secure. And we are making sure that as ARM, we make sure that all the developer experience is seamless, and each of this layer we have enough tools available, and we have a very robust developer experience. Okay. Now, moving ahead, I just wanted to do a quick introduction to something called ARM System Ready. Now, the philosophy behind ARM System Ready is that you have a lot of code that is being developed and a lot of code that has to be thrown out when you move to a different platform. And ARM System Ready is a compliance program that makes sure that once you develop a software, it can be reused across multiple platforms. Fundamentally, if there are system ready certified platforms, then a standard operating system like Linux can land on it right out of the box. And this makes sure that a lot of pain points that developers have in making the system boot, the non-value added task, all those are eliminated. So you can focus more on the innovation pieces and not worry about just making it work. So ST has been a good partner with System Ready, and they have a few products listed here, and we are actively working with them on additional products to make them System Ready certified. And hopefully the vision will be executed that the software will just work across different platforms, and there will be limited amount of code that is being thrown out because you couldn't port. So System Ready is a key part of our view of rich IoT and Linux. Now, I want to close off with a few call to actions. One is to visit the ARM Developers Hub. You will learn a lot about what we are doing with Linux, with Yocto, and many other developer-friendly tools. I would strongly encourage. I just gave a flavor of ARM System Ready. There is much more to explore. So I would encourage you to go to the ARM System Ready page on ARM's website. And with that, I will hand it to ST. So,
thank you, Chakra, and for sure our STM32 MPU are ARM-based, and we are very pleased to work with you to develop this nice products. So regarding the STM32 MP1 series, so these product lines are really being designed to meet the increasing demand on the industry 4.0, and though it is clearly done with industrial grade, and with a rich STM32 MPU ecosystem. Taking advantage of the STM32 MCU ecosystem with the well-known STM32 CubeMX to configure the chip following the application, to select the IOs depending the interface, and to really meet the customer requirement. Next slide, thank you. So what is the two pillars of this industrial grade? It is clearly the longevity, because we have a clear commitment for that. So our microprocessor, it is committed to have a 10-year longevity, and it is renewed every year. So each year you have a new year added on the longevity commitment. So it is one of our big engagement from ST. The other one is the robustness, because when we are talking about robustness, we commit to have 100% of operating time for 10 years in our STM32 MPUs. And after we have the connectivity coming with all the industrial application that we have on the market. Regarding the ecosystem, so we have a nice Linux distribution with the OpenST Linux distribution. We found a lot of things, and we have also some extension package which allow the customer to develop their own application with a lot of extended behavior. For example, with the Linux AI, which is a complete ecosystem that allows a developer working with our OpenST Linux to create Edge AI application very easily embedded directly in our distribution. You have, for example, some benchmark application tools inside. You could easily work with Python language. So it is clearly optimized to create this kind of AI application. So regarding the EV charging station requirement, so you see there the classic block diagram to achieve this kind of application, and we'll see how our STM32 MP1 portfolio could bring in this kind of application. So we will start with the STM32 MP1 free line. So in terms of control unit, so you are using a CPU based on the Cortex-A7 up to 1 GHz with the L1 cache for instruction and data of 32 KB, and you have a L2 cache to 128 kilobytes. In terms of memory, you could for sure place your code application in the eMMC, and you could run your code, your RAM using a DDR, DDR2, LPDDR2, or DDR3L at up to 533 megahertz with a 16-bit interface. In terms of connectivity, you will find the classic one, so the UART, the SPI, and the I2C. You also could use the CAN-FD to communicate with the electric vehicle. What could be very interesting regarding the new trend for this kind of EV charging, it is the possibility to use 2 Giga Ethernet. One could be used to connect all the EV charging pile together to allow the CPU to manage data coming from the different stations to optimize the energy distribution, for example. And the other Ethernet could be used to connect the global network and so have the internet access. And you know that now EV charger is for sure powered by the grid, but it is also good to save energy. We are still on the MP13, sorry. Yes, it is save energy. So it is very important to notice that, because even it is connected to the grid, it is not a battery powered system, but it's always important to save energy. And with this product, the power efficiency is really important for us and for ST. It is one of the best in class in terms of consumption in the market. And you could save over 90% in standby mode or in backup mode. It's really important. Associated with our power management IC, the STMicroelectronics, you could also clearly save energy, because this power management IC has really been developed and specified to work with our MPU. You could also, for example, use the DVFS, so the dynamic voltage and frequency scaling, to allow to control the CPU clock frequency as well as the supply of the chip, to have clearly the best compromise between performance and consumption. One other challenge on this new EV charging, it is the payment requirement, because for EV charger manufacturer, is not so easy to add payment, because it demands a lot of certification to have to be able to do that. And so with this product, the STM32 MP13, you have already this pre-certification for this device. For example, we have the PCI 6.0 pre-certification. The PCI, it is for the payment card industry. So it is one of the best robust class of certification. And this certification, this pre-certification, allows you to use this payment in your EV station. And why we could be PCI 6.0 pre-certified, it is because this product, for sure, it is the root of trust of all the system, because it is the major CPU of the EV charging. And so it is really important to start at the beginning with a high secure device. And it is the case with a secure boot, for sure, with a lot of cryptographic accelerator inside, like, for example, the elliptic curve accelerator inside with hardware logic inside. And so you have also ECC, CRC to have a nice offer in terms of security. You have also the possibility to encrypt and decrypt the DDR access to avoid some hacking on this connection. You have also all the monitor to be sure that some hackers can't be able to put the device out of its range of specification to try to steal some secret. And this could be possible with our monitoring of the temperature, the frequency, and the voltage. For sure, this product could also be used with Opti, so saying that you could have a trusted environment to put your secure application, and another place to place your classic OS code. This product also could be used with our calling what we call the SSP, so the secure processing, to be able to put some key in terms of again security features. And we could also add one of our component chip, the ST-Safe TPA, in terms of security, to allow us to meet the standard of the ISO 15115 to communicate with the electric vehicle, and also to do some user authentication with the OCPP protocol that coming from the charging point operator. So a very nice security solution if you want to add this kind of payment in some EV charging station. Regarding the other product of our STM32 MP1 series, we have the STM32 MP15. So this one, you add performance inside the control, because now you have a dual Cortex A7 running up to 800 megahertz, and you have also a Cortex M4 running at 209 megahertz. You have the same amount of Elwin cache for each core, and 256 kilobytes for command for the two core. In terms of performance, you also have a gain regarding the DDR, because you have now 32-bit data interface to access the memory. In terms of HMI, you have also a big enhancement, because you will find inside a 3D GPU to manage all the graphic stuff by hardware. So you could reach the resolution of Full HD at 30 frames per second, or wide EGA at 60 frames per second. What is also important to notice, it is that in the STM32 MP13, you have the RGB parallel interface, and on this one you have the MyPy DSI interface, which allows you to connect different display using this STM32 MP15 product. In terms of HMI, also you have a lot of things to do, some audio with I2S, PDM, SPDIF for transmitting and reception. And thanks to the hybrid architecture with the Cortex M4, you have also the possibility to clearly use the real-time feature of the M4. For example, to manage all the sensing in real time, so the temperature, to avoid any overheating of the system. You could also clearly check the humidity, play with the accelerometer and the time of flight sensor inside. And this Cortex M4 also could clearly help in terms of safety, to be deterministic with bare metal and RTOS, to do all the things in terms of interrupt management. What is also one of the new trends in terms of EV charging, it is the use of the AI. For example, on this product, you could use one of the CPU to manage this AI by software, using, for example, the XLNX AI extension package. For example, for doing any construction profiling, for example, by analyzing the grid computation, and so the AI algorithm can optimize the charging activities to reduce the impact on the grid, and be sure that the grid is clearly stable, and so reduce the electricity cost for the electric vehicle owners. You could also work with this AI to do some predictive analytics, like for the industrial predictive maintenance, to check and be sure that no default will be occur during the use of this station, and avoid any problem with the users. You could also imagine using the AI for the license plate recognition to check which vehicle is approaching the EV charging station, and so set up the user profile inside the pile. What is also very important to note after this explanation regarding our product, it is that you could find on our website on st.com all the PCB to do your hardware very easily. You will find all the PCB to connect, for example, the different DDR with the different package that we have, the PCB for the ST power management IC, and so all the signal integrity and power integrity have been done, and so you could be reassured to create your own PCB and create your board on your EV charger. Regarding the product, we have a complete family to offer for this kind of EV charging station. So you will find for sure the STM32MP15 series with different flavor, with dual Cortex A7 or just one with the Cortex M4 with different peripheral. The flagship, it is the STM32MP157 with all the feature, with the DSI display, with the 3D GPU, and for sure the dual Cortex A7 and the Cortex M4. For the MP13 family, we have also different flavor with the flagship, which is the STM32MP135 lines. Which is very important to know regarding this different flavor and different series. It is that these products are pin-to-pin compatible for one family. So next slide, please, Georgie. Sorry, thank you. So for example, for the STM32MP15, the 153 and 157, all these products will be pin-to-pin compatible regarding the several packages that you have. So you will find on this product line the smallest package for dual Cortex A, so a 10 by 10. Okay, so it's really important to notice, and you could reach a 4-layer PCB with that. So you could also have clearly optimized the bill of material with the high integration that we have with this package, with the possibility to use this 4-layer PTH. And what is also the same for the STM32MP13, we have the free package, which will be also pin-to-pin compatible regarding the different flavor of the device. So it is very interesting. So you could upgrade your product or downgrade your product following your needs and following the customer requirement. Which is also really important. It is for sure our ecosystem, because it is also for sure compatible between all this product line, and so you could use it very easily on the STM32MP13 or STM32MP15. So I am done. So thank you. I hand over to Pierre.
Yes, thanks a lot, Ludovic, for this really detailed introduction about the MP1 series. We will now deep dive into the software part of this webinar. So we will start by just having a great overview of what we are talking when we are talking about EV charging solutions. So we already have an introduction about the hardware. I will not get back to that now, but we will focus a little bit more on software. So here we are talking about software stacks first. So we have operating system that is needed to run your EV charger solution. You will need to run an application or a set of services that will use some frameworks, that will use some software stacks, and having the grid and the appropriate bricks, layers, IPs is not does not mean having the best solution. For having the best solution, you also have to work on the right methodology, and that's why we will also talk today about secure by design. What does that mean? Agile and user-centric experience, and also think about the long-term maintenance. Be ready to support your product on long term, because it's not a product you are delivering for 1 year. It's a product you will deliver for 10 or 15 years on the field. At the end, all of this hardware plus software plus good methodology will give you the key success factor for a product. And there is an important topic that we will also discuss today about how to shorten the time to market. So let's deep dive into that stuff and start with the operating system. For the operating system, I only focus today on Yocto. All the silicon vendor, all the board manufacturer, everybody today support Yocto for embedded Linux. So we are convinced at Witekio that it is one of the best solutions for embedded Linux development. Why is that? Because you can customize your system, really reduce the image to a minimal one, only including what you need, which is good for the optimization, which is good for cybersecurity, and because minimization is a key topic in cybersecurity. You have great documentation, you have a community with a lot of support. So Yocto is, yeah, one of the best solutions for embedded Linux. Maybe one of the complexity will be to manage that stuff. That needs to understand the principle of Yocto, that needs to understand how it works. But as soon as you will master this stack, you will be able to create your own Linux image with a really fine approach. Let's continue with, on top of this operating system, we are running application or services. And for that, you have dozens of frameworks. Here are some of them we are used to use in this industrial embedded world. But in fact, the real question will be how I can select the appropriate stack for me. And there is multiple ways to answer to this question, but you will have to define your own criteria. What is exactly your needs? What are your ambition? How is you compose your team? What are your actual knowledge? Are you working on a single product or on a range of products? Definitely, we can helping you if needed to start thinking about how should I build my application on top of my Linux. And each stack will have pros and cons. So it could be interesting to understand more your context to be able to define the right solution. Let's continue with norms and protocol. Today we will just address two of them, but the two most important we are talking about EV charger. So it exists ISO 15118, which is a protocol to allow communication between the electrical vehicle and the EV charger. Depending on the version of the protocol, you will be able to get more or less information coming from the vehicle to the EV charger, like capabilities in terms of loading, and there is a lot of information that can use for optimizing the loading of the electrical vehicle. On the other side, between the EV charger and the charging station management system, so the operator application that is managing, which is usually a website or at least a cloud-based solution, you have this OCPP protocol with the most classical version today, that is the most deployed, which is the 1.6, but there is a new 2.0.1, which is currently coming. And if you combine these two protocols on their latest version, you will start to have some really interesting features like smart TV charging, the famous plug and charge, where user does not need anymore to authentify. The car will be directly authentified to the charging station management system going through the EV charger. The security also have been drastically improved with the latest version of the firmware. The last version of the OCPP allow you to support the firmware update for your EV charger. And we have some advanced features like vehicle to grid, which is something not yet really deployed, but that could come in the future for managing this famous smart grid in the global energy management of a system. We have seen the different stacks. Let's focus a little bit more about methodology. So here we are talking about secure software development lifecycle. We are also talking about secure by design. What is important here is just to understand that there is different steps all along the development of your project. And at all of these steps, you will have to integrate cybersecurity by thinking about, for example, at the very beginning of a project, you are working on a vulnerability analysis, attack tree, how my system, and before starting the development, how my system can be attacked by some external users. Then you have the security requirements that will be given by this attack tree, and you start building your security solution. Then during the development, you will have all the security mechanism to implement. Should I implement secure boot? Should I implement secure provisioning? Should I use containerization? And at the end, you have your operational use with the day-to-day monitoring of your cybersecurity by monitoring your infrastructures, but also monitoring your vulnerabilities, or what we call CV, into your system. On the right part, you find a lot of keywords that are all technical words for some cybersecurity solution that could be provided, that could be implemented into your system to implement a high level of security for your charger. I continue with methodology, and here we are just an introduction of how we are working with our customer when they need to implement a Linux solution. So we call that Linux Fast Track, because we already have a set of tools that is useful to implement a dedicated Yocto image tailor-made for our customer. And what kind of activities managed into this development of Linux? We are talking about driver configuration. In some cases, we can add some extra drivers, the Linux kernel configuration, the file system configuration, the OTA update. Here is a very important topic. As soon as we are talking about embedded or connected equipment, being able to support over-the-air update is something important. And usually we start all of our project by implementing these features before the others. These features have to be really robust because it will be something key for your fleet management. And it exists a lot of different technical solutions for that. We can talk about Mender, we can talk about SW update, we can talk about Rock. Once again, like for the technology we have seen at the beginning, let's talk together to define what is the most appropriate solution for you. If I continue with our Linux fast track way of doing, so cybersecurity hardening, how and which type of cybersecurity solution we put in place into your Linux. We are also talking about continuous integration. That's another key topic for the quality perspective, how to integrate the solution into an automated build environment, automated testing environment, automatic delivered environment. That will drastically help to improve the quality of your product. And at the end, we also provide an example of application, like a starter kit to develop your own application. Let's take an example. Maybe you have already seen this sample EV charger we have developed internally at Witekio based on STM 15.7, STM MP1 and 15.7. You can see some screen we have implemented with a UX workflow to manage the charging. And on the right part, you can see all the technology we have used and integrated all together to achieve industrial grade solution. So we are talking about the STMPUs series. We are using Yocto. We are using the embedded kit as a Linux distribution. We are using on OpenST Linux for the BSP parts and implementing Linux on top of the MPUs. We are using Mender for the OTA, Qt for the graphical framework, GitLab for the DevOps platform, Pluma for the automated testing. So you can see here we have really integrated all the different stacks and all the different technology which are best in class for implementing such type of solution. Let's continue and finish by this long-term maintenance, because we really would like to talk today about long-term maintenance. That's really important to develop a high-quality product, but if we stop maintaining in the long time, it will just be an issue for you and your customer. So thinking about long-term maintenance is a key topic. We also at Witekio support our customer with an offer of long-term maintenance for the Linux Yocto image. So how does it work? We are really working on a weekly cybersecurity monitoring. That means detecting all the CV applicable to the Linux solution. We can alert our customer about this CV. We have a process to patch these vulnerabilities into the Linux with a real development process that will be based on a different branch of Git to ensure our customer can continue their standard maintenance while we are doing the cybersecurity maintenance. And we are also providing the LTS update, so implement Yocto and kernel update on a quarterly or yearly basis, depending on the part of the system, to ensure that you are always up to date for your system and you are ready to go for a long time. And I think that will be everything for me today. Maybe just one key takeaway. I just reuse this DevOps cycle. In fact, you can also talk about the DevSecOps platform. So dev, development, ops is for operational and maintenance, and the sec is for security. So if this is something that is usually done in standard IT development and that we really try to implement into embedded world. So trying to follow this type of DevSecOps cycle is something which become key to ensure product quality. So thinking about the development, the right stack, but also the long-term maintenance is something that we consider as a key success factor. And using the right hardware is also a key success factor. Ludovic?
Yeah, thank you. For sure, you have to maintenance and to do this long-term maintenance in terms of software. You need a commitment for the hardware for a customer, and so the STM32 MP1 series is there with its 10 years longevity commitment, renewed each year. So that's both of this software and hardware solution that allows the customer to be peaceful on this long-term application.
Just before we start the questions, just a quick reminder that this webinar is from Witekio, so I have to do a very, very quick pitch. You can't blame me, I'm so sorry, but Witekio do everything for your embedded software needs. As we said, talking everything from applications to low level to cloud connectivity to security. And we are partners with the best people such as ST and ARM, and of course the embedded kit, which is our product range, which Pierre was talking about. So we're going to move on to questions now. Thank you so much to all of our speakers and to everyone for joining. And I'm welcoming Vincent, who is the ecosystem manager for ST, to the stage as well to help answer some more questions. Does anyone have any, or I have a few from emails from before the webinar began. But if anyone wants to ask any in the chat, then we are here and we have a few minutes to do it. So whilst people chat away, I'm going to ask a question, which is, this one is based to ARM, actually, to Chakra. Can you tell us about how System Ready ties in with Linux?
Sure. So System Ready is mainly for the hardware. So it's a hardware certification. And so the relation is that once a hardware is certified to be system ready, then any standard Linux operating system, any standard Linux distribution, it can simply boot on it without any changes. So that's the connection. System Ready ensures that any standard Linux can basically run on it.
Okay. Amazing. For Witekio, for the software side, we've had a question asking, in the maintenance, how are you managing vulnerabilities? So is there a set way that we do it?
That's a good question and long question. In fact, we are doing on a regular basis CV analysis. So we are using a dedicated tools for doing CV monitoring of the applicable vulnerabilities of on a specific Linux image. Then we have some specialized engineers that have cybersecurity and also Linux knowledge that are able to analyze the impact of the different CVE, the different vulnerabilities on the system in the context of our customers. And then we apply a remediation to all of these issues. So we can find appropriate patches and apply it. We can backport some patches available on other version of the system we are using. We can find some workaround in some specific use case. So we really have a dedicated process to manage that for our customers.
Okay. This one's from me, really, just because I was interested for Ludovic and for ST. So obviously you showed the slide where you had a kind of a perfect setup of, if you want to bring an EV charging solution to market, these are all the different things that you could get. If someone is watching, and obviously they're interested in ST, they're interested in ARM, what is the best way for them to kind of talk to you about it? Is everything on your website, you know, to go, this is how you set up, or should they contact ST and you can talk them through the hardware they'd need to do it?
Yes, most of the information shared in our website. So we'll find a lot of things in st.com, but you have also a wiki to find a lot of information to start with our MPUs. You have also for sure a GitHub page to our OpenST Linux solution. So you also have a lot of information, regarding the STM32 cube, which is also on the website. So yes, you will find all this information and all the information you need on the st.com website.
Okay, amazing. I will put, along with Chakra's ARM system ready in the slides, obviously, I'll include some links to the ST GitHubs and everything that Ludovic just said, so that everyone, when I send the slides out, has access to what you need to see. Unless there's any other questions, I think it's good to leave it there. We're just a tiny bit early, but that's all good. We'll save these lovely people some extra time. And for everyone watching on demand, if you do have questions, then please feel free to reach out and I will send them to the speakers as needed to answer questions and to get back to you. So to all of our lovely speakers, thank you so much for joining us. And thank you to everyone for watching. Have a lovely night. See you later, guys.
Thank you. Bye-bye.
Thank you. Bye.